Hi guys, Prashun once again. Today we will discuss about some of the problem and solutions of complex number. In my earlier lectures or earlier tutorials, we have discussed about the theory portion of complex number. We have deduced what is a complex number, what is I, what is imaginary cube root, what is a Argand plane, or what is the polar form of complex number. So all these topics we have discussed, and we have discussed some of the formulas associated with complex number. uh, Cube root of unity also we have discussed. So here what we will do, we will discuss some of the problems and solutions, like how we are deducing to this factor. These are coming in these examples I have taken from some of the previous year WB joint entrance examinations or from your textbook, so that the topic can be well understood, and we will come for the complex and harder problems later on. Okay, so let's problems and solutions of the complex number. Let's take example 1. Evaluate the following expressing your answer in Cartesian form, that is a plus ib. Sometimes you will find in such a way that they will tell you that express your answer in the Cartesian form. They won't tell that it is a plus ib. So if they tell that express your answer in Cartesian form, it means that it is in you have to derive the complex number into a plus ib format. Or sometimes they can directly write that express your answer in a plus ib form. So whatever may come in the examination. So number 1 is 1 plus 2i into 4 minus 6i whole square. So we first let's write 1 plus 2i into 4 minus 6i whole square equal to 1 plus 2i, then 4 minus 6i whole square means a minus b whole square. So I have put 4 square, that is 16, minus 2ab, 2 into 4 into 6i, plus b square, that is 6i whole square, equal to 1 plus 2i, that is common, then 16 minus 2 into 4 into 6, that is 48, and I plus 6i whole square, that is 36i square. So next 1 plus 2i into 16, I square equal to minus 1, so 36i square will be minus 36 and minus 48i. So again we can further simplify. 1 plus 2i into 16 minus 36 equal to minus 20, so minus 20 minus 48i equal to, we are summing, we are just putting the multiplication. 1 plus 2i into minus 20 minus 48i, that is minus 20 minus 48i minus 40i and minus 96i square, because 2i into 48i, that means 96i square. I square equal to minus 1, so minus 20 minus 48i minus 40i, 48i minus 40i, that means 88i, and 96i square equal to minus 1, so that will come as plus 96. So minus 20 plus 96 minus 88i equal to minus 20 plus 96 equal to 76 minus 88i. So 76 minus 88i, you can see that is in the Cartesian from a plus ib. A equal to 76 and I is common, and b equal to minus 88. Let's go to the next problem. Next one is 1 minus 3i whole cubed. So we have to reduce this in the Cartesian from a plus ib. So how to reduce it? This is 1 minus 3i whole cube equal to 1 minus 3i into 1 minus 3i whole square. So any cube can be, x cube can be written as x square into x. 1 cube can be written as 1 square into 1. 2 cube can be written as 2 square into 2. Similarly. So 1 minus 3i into 1 minus 3i whole square equal to 1 minus 3i, then 1 minus 3i whole square, that is a minus b whole square. So a square minus 2ab plus b square. So 1 minus 2 into 3i, that is 6i, plus 3i whole square, that is 9i square, equal to 1 minus 3i, then 1 minus 6i plus 9i whole square, 9i square, I square equal to minus 1. So 1 plus 9i square, so 1 minus 9, that is minus 8, and minus 6i. So if I just multiply this, minus 8 minus 6i plus 24i plus 18i square. So minus 8 and 18i square, 18i square equal to minus 1, so that becomes minus 18. So minus 18 minus 8 becomes minus 26, and minus 6i plus 24i, that becomes plus 18i. So here that is in the form of a plus ib, a equal to minus 26 and b equal to 18. Another problem, that is I into 1 plus 7i minus 3i into 4 plus 2i. We just multiply the things, like I into 1, that is I, plus 7i square minus 12i, because 3i into 4, that is 12i, minus 3i into 2i, that is minus 6i square, equal to I square equal to minus 1, so minus 7, minus 12i, again I square equal to minus 1, but here there is a term of negative, so negative into negative positive, so plus 6, equal to minus 1, minus 7 plus 6 equal to minus 1, and minus 12i. Next problem is 1 minus 2i divided by 3 plus 4i minus 2 plus I divided by 5i. Here we can write 1 minus 2i divided by 3 plus 4i minus 2 plus I divided by 5i. 1 minus 2i into 3 divided by 3 plus 4i, I will multiply this with the complex conjugate of 3 plus 4i, that is into 3 minus 4i divided by 3 minus 4i, because as we are multiplying both numerator and denominator with 3 minus 4i, so it just doesn't matter. And 2 plus I divided by 5i, we will multiply with minus I as in both numerator and denominator. So it becomes, for the left hand expression, that is 1 minus 2i into 3 minus 4i, we are getting minus 5 minus 10i, and in the denominator it is 3 plus 4i into 3 minus 4i, that means a square minus b square, is a is 3 square minus b square equal to 4i whole square, I square equal to minus 1, so that becomes plus, so plus 4 square, into 2 plus I into minus I, that becomes 1 minus 2i divided by 5i square minus, so here both I negate, so equal to comes minus 1 by 5 minus 2 by 5 into I minus 1 by 5 minus 2 by 5 into I equal to minus 2 by 5. So that is the simplest result. Next we will go to the example 2. Compute the absolute value and the conjugate of z equal to 1 plus I whole to the power 6 and b omega equal to I to the power 17. We know how to find out the absolute value, and we know how to find out the conjugate. So let's see how we can proceed. Z equal to 1 plus I whole to the power 6. 1 plus I, this whole to the power 6, this portions we can write as root over 2 cos pi by 4 plus I sin pi by 4 whole to the power 6. This expression we can write from the Argand diagram. We have seen 1 plus I equal to root over cos pi by 4 plus I root over 2 sin pi by 4. If you cannot remember, you have to go to the theory portion. Now root over 2 whole to the power 6, that means 8, and cos pi by 4 sin pi by 4 whole to the power 6 means that 6 will come in the cos, so cos 6 pi by 4, that is 3 pi by 2, plus I sine 3 pi by 2, that is coming as de Moivre's theorem. So from here 8 into cos 3 pi by 2 plus I sine 3 pi by 2, that means minus 8i. Hence modulus of z equal to 8 and z inverse equal to 8i, because z inverse will be the conjugate will be negative reverse sign of 8i. Here the sign is negative, so that will be positive. So inverse of z, that is conjugate of z, equal to 8i. Next one is omega equal to I to the power 17. I to the power 17 I can write as I into I to the power 16. I to the power 16 again I can write I to the power 4 whole to the power 4. I to the power 4 I know, that is 1. So 1 to the power 4 equal to 1. So it means I. Hence omega, modulus of omega equal to 1, because root over a square plus b square, and omega inverse, that is the conjugate of omega, that is minus I, because it is I. Example 3, compute the cube roots of z equal to minus 8. The trigonometric form of z equal to minus 8 is z equal to 8 cos pi plus I sin pi. Then cube root of 8 of cos pi by 3 plus I sin pi by 3, that will come as cube root of 1 z. It means 2 cos, cube root of 8 means 2, and cos pi by 3 plus I sin pi by 3. So that becomes 1 plus I root 3, because cos pi by 3 and sin pi by 3 absolute value will put, and it will come as 1 plus I root 3. Again another root will be cube root of 8 cos pi plus I sin pi equal to cube root of 8 means 2, cos pi plus I sin pi equal to minus 2. Another root, that is z3, equal to cube root of 8 cos 5 pi by 3 plus I sin pi by 3 equal to 2 cos 5 pi by 3 plus I sin pi by 3, which means 1 minus I root over 3. The 3 roots of z cubed. Next example, find the multiplicative inverse of the complex number 4 minus 3i. Let's see how to find out the multiplicative inverse. Let's consider z equal to 4 minus 3i. So z inverse equal to 4 plus 3i, that is the conjugate, and modulus of z square equal to 4 square plus minus 3 whole square, that is 16 plus 9 equal to 25. So the multiplicative inverse of 4 minus 3i is given by z inverse equal to conjugate of z, that is conjugate of z and divided by z square. Conjugate of z is equal to 4 plus 3i, and z square, modulus of z square, equal to 25. So it becomes 4 by 25 plus 3i by 25. Next problem is example 5. Find the multiplicative inverse of the complex number root over 5 plus 3i. Similarly we will do, let's consider z equal to root over 5 plus 3i. So z inverse equal to, conjugate of z equal to root over 5 minus 3i, and modulus of z square equal to root over 5 whole square plus 3 square, that is 5 plus 9 equal to 14. So the multiplicative inverse of 4 minus 3i is given by multiplicative inverse of z equal to complex conjugate of z divided by z square. So complex conjugate of z equal to root over 5 minus 3i divided by z square Z square means modulus square, so that is 14. So root over 5 by 14 minus 3i by 14. So that's all. These are the few problems and solutions which are very easy. I just described this because of the reason that it is just simple. I know that few came in joint entrance and few did not came in joint entrance. Few or may not be that much tough problems, but this will give you a base, and in the next tutorial we will go to some harder problems. Thank you. Thanks for watching the video. If you like, please click on the like button and subscribe me so that this video can reach to the wider audience. Thanks once again. Have a good day.